This podcast is going to move a little bit quickly, so you might have to pause it from time to time. Go at your own pace. If you need to look back at the steps, then just rewind it. There is one section on upper and lower bounds that I'm not going to cover on here, but you can read about that in the book. Okay, we are going to finish up section 2.4, just a review of what we've covered so far. The main thing is that when you do synthetic division, the remainder is the same number as if you just plugged it into the polynomial. It's called the remainder theorem. Second thing, if your remainder happens to be 0, then you actually lucked out because you found a factor, and hence you found a 0 for the polynomial, which is what we've been looking for. Third thing is, if the remainder is 0, not only have you found the 0, but you've also found a factor, and you found the other factor. So what do I mean by this? Let's work this out with the following example. So go ahead and write this down as our first problem. You might want to pause the podcast to do that. Okay, here's the problem we're working on. So I'm going to just go ahead and write down the coefficients, 3, 2, negative 7, 2. Remember, what goes in the box is what makes that 0. So negative 2 is going to go in the box. Bring down to 3, multiply by the box, negative 6. Negative 4, multiply by the box, 8. Positive 1, multiply by the box, negative 2, and sure enough, the remainder is 0. So what good does that do us? Well, if the remainder is 0, that means x plus 2 is a factor. Well, what is the other factor? If you remember, the other factor is this guy, 3x squared minus 4x plus 1. And what's good about this is once you get it down to squared, you can easily factor that. So I got the x plus 2, and then this, you can just kind of work it out, 3x and x, 1 and 1, minus, minus. So after this step, you got all your solutions. X is equal to negative 2, x is equal to 1/3, x is equal to 1. Okay, and as expected, since the degree is 3, I have 3 answers. The questions we want to look at today is, what if we're not given any factors? Okay, is there a smart way to guess numbers that go in the box? And if we can get maybe some possible guesses, is there a way to narrow it down so that we don't have to try all the guesses? Okay, so here is the first problem. Go ahead and pause the podcast to write it down. So here's problem number 1. Notice I don't have a single number I can use as even a first guess. So I could just try randomly, or we can be smart about it. I'm going to call the last coefficient p. And what p is are all the factors that make up that number. So how can you multiply to 2? Well, 1 or 2. Technically, these are plus or minus 1, plus or minus 2. The first coefficient I'm going to call q. So q is all the ways you can multiply to 3 in this case. Plus or minus 1, plus or minus 3. Our guesses are going to come from here, and what we're going to do is we're going to put p over q. So these are rational or fractions. All the possible combinations. So I can go 1 over 1, 1 over 3, and that will give me some possibility. Plus or minus 1 over 1, plus or minus 1 over 3. I can also go 2 over 1, 2 over 3, and those are going to be some more possibilities. So plus or minus 2 over 1, plus or minus 2 over 3. So in total, I have 8 choices to choose from in terms of what goes in the box. So I'll write the coefficients, 3, 4, negative 5, negative 2. And at this point, until we get some more details, we're just going to guess. So I'm going to pick a random number, just see if it works. Easiest thing to try is maybe going to be x equal to 1. So 1, bring down to 3, multiply, 3, add, 7, multiply, 7, add, 2, multiply, 2, remainder 0. So it worked. So what that tells me is that one of the factors of this polynomial is x minus 1. Well, what's the other factor? The other factor, remember, comes from here. 3x squared plus 7x plus 2. Okay, and again, what's great is once you have it down to quadratic, you can just either use quadratic equation or factor down. Turns out this factors 3x and x, 2, 1, plus, plus. So our two solutions for this particular problem, or our 3 solutions, are x equal to 1, x equal to negative 1/3, x equal to negative 2. Let's try the next example. You can go ahead and write it down by pausing the podcast. again, I'm going to call P my last coefficient. So all the ways to multiply to 9 are plus or minus 1, plus or minus 3, plus or minus 9. I'm going to just write the plus or minus in the front. The lead coefficient is Q, so in this case it's 1, which is great because it's just plus or minus 1. Well, that makes life a lot easier because P over Q is just 1, 3, and 9 all over 1, but I don't need to write that. So let's go ahead and set up this synthetic division, 1, 3, negative 9, and decide what goes in the box. Okay. Again, it's from these 6 choices, so you can just go ahead and guess one. I'll just try, for example, 3. So 1, 3, 6, 18. It's already not looking good, right? So maybe 3 was a bad guess. So let's erase that, and instead of 3, let's try negative 3, just see if maybe that'll work. So let's see, bring down the 1, negative 3, 0, 0, negative 3, 9, 0. Great, so it worked. So what that tells me is one of the factors is x plus 3. The other factor, remember, comes from this guy, which is x squared plus 0x minus 3. Okay, and I want to find where these are equal to 0. Well, this one we already know is x equal to negative 3. This one doesn't seem like it's factorable, but it's okay, because I'm just trying to solve this, and I can do that by just simply finding x, or you could use quadratic equation if you really wanted to. So it looks like you have 3 solutions as expected. Here's a third problem, and the reason I want to go through this is there are just a lot more choices, or a lot more factors, because I'm going to need to find 4 of them. So P are all the factors of 8, which in this case are plus or minus 1, 2, 4, and 8. Q are all the factors of the lead coefficient 2, which are just 1 and 2. So P over Q might generate quite a lot of choices. So I'm going to go 1 over 1, 2 over 1, 4 over 1, 8 over 1. 1, 2, 4, 8. And then I can go 1 over 2, but look what happens. 2 over 2 is just 1, it's already there. 4 over 2 is just 2, which is already there. 8 over 2 is just 4, which is already there. So all in all, I have 10 choices to work with. Okay, let me go ahead and prepare this for synthetic. 2, negative 7, negative 8, 14, 8. And at this point, again, it just becomes guesswork. Okay, to save us time, I'm going to pick one that works. 4, it turns out, is going to work. So if I bring this down, 2 multiply 8, add 1, multiply 4, add negative 4, multiply negative 16, add negative 2, multiply negative 8, remainder 0. Great. So what I know is that x minus 4 is a factor. Well, the other factor, we went from x to the 4th, so we always knock it down, right? So it's going to go like this. So it's going to be 2x cubed plus x squared minus 4x minus 2. Okay, there are ways to factor this, but let's assume for the time being that I don't have any tools to factor a term with a polynomial with 4 terms that's cubed. What you can do is you can do synthetic one more time. Okay. You can do the P over Q again, but your choices are actually the same. They're all from here, but you can notice that P over Q won't have 8 or 4, so there are a couple bit, it's a little bit narrowed down. I'll just give us the one that works, which is negative 1/2. Bring it down, multiply, negative 1, 0, 0, negative 4, multiply 2, 0. Great. So what have we found? We found, for this one, that the first factor from before was x minus 4. The new factor that we just found is x plus 1/2. Okay, and then the last factor from there is going to be from this guy, 2x squared plus 0x minus 4. Okay? Once I'm down to quadratic, I'm always done because I always have a way to solve quadratic. So we know these answers because we already found them. This one, again, I can just hit 2x squared minus 4 equal to 0, and you can solve for it and show that x squared is equal to 2. So x is equal to plus or minus square root of 2. So you got 1, 2, 3 answers. I want you guys to notice, if you didn't notice earlier, that this was not one of the P over Q choices. Well, why is that? Because P over Q only gives rational roots. So it only is good for zeros or roots that are clean fractions. not radicals. So it does have some limitations.